So now let's continue to describe those contractual terms. First, let's look at the rebates contract. Suppose the manufacturer wants to offer a rebates contract. The manufacturer needs to offer Q, R, and T. Q is the order quantity or the production quantity. R would be the per unit sales bonus for the retailer. And finally, to get Q and R, the retailer needs to pay T as the transfer payment. Okay? Here, one important thing is that the manufacturer is not restricted at the wholesale price. No one says that the manufacturer needs to offer a wholesale price and needs to restrict himself at a linear pricing scheme. Okay? If we want to find the optimal rebate contract, we cannot do so. We cannot put this kind of restriction on the search space. We need to allow T to be depend on Q and R in any format. Can be any kind of functions. Okay? So that's something to remind you. Q, R, and T can be anything depending on Q and R. Similarly, if we want to discuss a returns contract, the manufacturer needs again specify three things: Q, B, and T. Q is again order quantity, T is again the transfer, and B is now the buyback price for each unit of unsold products. Again, the manufacturer still is not restricted at a wholesale price. T can depend on Q and B in any possibility, in any format. So with that in mind, what's the manufacturer's contract design problem? The manufacturer designs a take-it-or-leave-it contract. The retailer cannot choose quantities by himself or by herself. The retailer can only accept or reject the contract. Okay? So the manufacturer is saying take it or not. The retailer can only accept or go away. But here, the retailer's information allows her to make this decision more accurately, right? Because, for example, if the quantity is very high, then for the retailer, if the retailer sees a bad signal, he believes that the demand would be bad, and that's how he says rejection to the manufacturer. If the retailer does not have that information, then she will not be able to make that kind of decision easily. So, as we all have learned, we know there is the so-called revelation principle, and that's why if the retailer does not forecast, the manufacturer only need to offer a single contract. But if the retailer has private information, then the manufacturer need to offer a menu of contracts, and that menu of contracts must induce truth telling. Because S is binary, there are only two types of consumers, so we only need two contracts in our menu. We assume that the manufacturer cannot mix rebates and returns. Eventually, you will see that this is indeed not required. And finally, as we mentioned, the retailer can determine whether to forecast or not. That means whether to obtain private information or not. Okay? So this is a problem with endogenous adverse selection. It is one of those players. It is the decisions that creates information asymmetry. Okay? It's possible to have no information asymmetry depending on the retailer's decision. So now let's review timing. The sequence of events is the following. First is the manufacturer to offer the contract. Facing those contracts, the retailer then decides whether to forecast or not. If the retailer forecasts, she will privately observe the demand signal. And then the retailer can choose a contract based on her signal, based on her knowledge. And finally, demand would be realized and the payments will be made. In this case, following this timing, we say the manufacturer can somehow induce the retailer to or not to forecast, right? Because the retailer makes this decision according to the manufacturer's offer. So the manufacturer can adjust his offers to change the retailer's behavior. In particular, even though no one can really observe the retailer's forecasting action, however, the manufacturer will be able to anticipate whether the retailer forecasts or not. Okay? Because everyone is rational, the manufacturer can solve the retailer's stage 2 problem. And the manufacturer will be able to know, given my offer, will you forecast? The following alternative timing is not discussed in this paper, but I suggest you to think about if the game becomes in these formats, what will happen, what will be changed, and what will be unchanged. The one possibility is for the retailer to forecast after choosing a contract. That means 1, 3, 2, 4. Another possibility is for the retailer to forecast before getting the offer, means 2, 1, 3, 4. Okay? You may think about the information structure may change, and how they interact will change. In particular, try to anticipate what's going to happen in these new settings. So now we are able to precisely describe our research questions. The first one is, should the manufacturer induce the retailer to forecast? Both of them are profit maximizers. Okay, they want to maximize their respective profits, expected profit. So is it optimal for the manufacturer to induce forecasting? If so, how should the manufacturer do that? How to decide whether to use rebates or returns, and what are the 3 parameters to set? In particular, we want to answer which type of contracts, rebates or returns, is optimal to the manufacturer. Okay? If the manufacturer can choose between these 2 options, which one should he do? Should he choose? With all these questions, what we really want to address, what we really want to show you is, again, the efficiency versus inefficiency problem. And in particular, we want to see what kind of incentive issues and information issues creates, for example, inefficiency, or under what kind of situations may we attain efficiency. Okay, that's our general issue. So now let's study this integrated system. As a benchmark, we always want to first analyze this first best situation integration. Here, the decisions will be forecasting or not, and the production quantity. Note that these 2 are external decisions. These decisions are made outwards or outgoing decisions from the system. When we are discussing integrated systems, we don't care about internal decisions like buyback price, like per unit sales rebate, like transfer payments. Okay? Suppose the system do not forecast. In that case, we are facing a very simple news vendor problem. Here, the demand is Dn. Because we do not forecast, we don't know what's the demand. So we use this estimation, and then we get optimal quantity. This quantity definitely depends on our belief on the demand, which is Fn as the CDF. If, on the other hand, the system chooses to forecast, in this case the quantity can be different. Okay? When I see a good signal, I expect the demand to be high, and I'm going to make my quantity higher. Or if demand is low, I'm going to make a lower quantity. I still determine the quantities according to the news vendor formula. Here, what's interesting is that it is because that we have the ability to adjust our quantity that we get some benefit. If there is no adjustment, that means QH and QL are the same, then forecasting is really not beneficial. We can mathematically show you that when you do not forecast, if the order quantity is Q, and if you fix to this quantity, then forecasting and getting more information does not create any benefit to you. Okay, which is kind of makes sense. Okay, so now we have the forecasting, the profit with forecasting and the profit with no forecasting. If the forecasting is free, we can show that the system should always forecast. I hope that's somewhat intuitive. If information is free, if this is the integrated system, why not get all the information? Okay, so mathematically we can show this is something we have, okay, in the previous slides. And moreover, from here to here, this means we adjust our quantities according to our information. Definitely that can create some benefit, right? Okay, so however, what's the bad news is that forecasting is not free. So the system should forecast or not depends on the value of the cost. Naturally, we define the gap between the profit under forecasting and the profit under no forecasting. We define the difference as Ki, and Ki provides a threshold for we to determine whether to forecast or not. If the cost is so low, the system shouldn't forecast. Okay, it's economic to do that and produce QH or QL, QHI and QLI according to the information. However, if the cost is too high and it is not worthwhile of doing that, then we should simply produce Q and I with no information. This is the best we can do. Okay, so in summary, there is a threshold policy. When K is small, forecast. When K is large, do not forecast. Okay, keep this threshold in mind, and at the end we will compare this with other thresholds.